Let's talk about. I just want to go back. I just want to make sure that we are reiterating some ideas. I think maybe it got lost a little bit in what the difference between random sampling and simple random sampling. In random sampling, the idea is if I've got this population, let's say, now you probably wouldn't choose this many things to be in a sample out of a population like this, but let's say I choose randomly that object, that one, and that one, and they become a sample. Okay, so I'm going to come over here and write sample. I'm going to call it sample 1 and put those 3 things in it. Okay, so what we talk about a random sampling is that sample, the probability of that sample being chosen is the same as sample 2 being chosen when I choose maybe those. Which then would be the same as if I chose a third sample, which maybe is these purple ones. Does that kind of make sense to everybody? So the idea of a simple random sample, by definition, it says that this sample here, and I only did 3, but I could have an infinite number of them, that each sample is as likely to be chosen and developed as any other sample. Does that make sense? Okay, so if this class was a population and I chose 3 of you, okay, and that sample was created, then that sample's probability of being created is the same as any other sample of the same population using 3 people again. Okay, is everyone okay with that concept? Simple random sampling, then, is the idea of now attaching a number to each one of these people in the population, or items, objects in the population, and then using like a number generator to actually pick out the sample. Is that all right with everybody? Okay. Just wanted to make sure that was clear. Cluster sampling, kind of maybe draw a picture here, the difference between cluster and stratified. So if we've got a population, let's see here. In both of them, okay, so in a cluster and a stratified, you're going to have groupings. So let's call this group 1, these 2 columns, group 1, group 2, group 3, group 4, okay? In stratified, what we are going to do is we are going to choose out of group 1, we will simple random sample and maybe choose those 3. And then in group 2, maybe we come through and those are the ones that we choose. And then maybe in group 3, it's those. And in group 4, it's those. So we simple random sample out of each strata. Then those all come down. Those 3 in each one of those groups, and they make my overall sample. Does that make sense? Okay, that's stratified. In a cluster, it's actually a little bit easier to think about in a cluster. If that's group 1, group 2, group 3, group 4. They're in groups, or I put them in groups. Okay. What happens here is we randomly select one of these groups. So maybe we do a number generator with 0, 1, 0, 2, 0, 3, 0, 4, and whichever one gets chosen, maybe 3 gets chosen. That there, I take everybody out of there, and that then becomes my sample. Does that kind of make sense? Okay, so that's the difference. I know when you read the vocabulary or the definition, they sound very similar, but there is some structure difference between the two terms. Okay, I would be cautious of a cluster. Okay, I think that could maybe, because sometimes a lot of times the way people are clustered, if they're already predefined clusters, and those people usually maybe have some similar characteristics. We talked about like faculty being broken up into math department, English department, science department, and if they use the math department, then we all have kind of somewhat similar characteristics that maybe the entire population of faculty doesn't have. So I would try to be cognizant of that when I'm doing that research. Riley. I can't. What'd you say at the end? They're not. Yeah, but they're not specific because we don't know who those people are that are getting picked. We don't want to. In anything we do, we're not going to go target a particular individual or object. Does that make sense? Because then there's bias in that. But if you think, I kind of do think that there is a link between the individual aspect, because I'm going into individual groups and pulling out individuals that become my sample, where here, there's no individual analysis. I'm not looking at individuals here and pulling them out, individuals here. It's just, I'm just going to take that cluster. I agree that sometimes with mathematics, we name things, or they've been given names that may be somewhat misleading. Just is what it is. I don't know a way around it. The one thing to talk about with strata is that we talk about if they're disproportionate in size, then the number of sample or number of objects I take from each for my sample needs to be proportionate to the population. So if group 1 is twice as big as any other group, then group 1 needs to have twice as many members in the sample. And that's, we could sit down and do that simple calculation of figuring out the percentage that group 1 is of the population and determine what we need to pick. Okay. We ended yesterday talking about sampling error, and what I want to talk about is the idea that when we take a population, okay, that is a big group of people, and we take a sample out of there, okay, the sample statistic, okay, so the number that is attached to that is represented, trying to represent the population, that number right there, and we'll call it the statistic, okay, is going to be different than the population parameter, right? Now, they should be, if we've done our due diligence and we've set up our research correctly and we've tried to eliminate as much bias as we can in the process of gathering this data, then they should be in the ballpark of one another, but they're going to be different. Another thing to think about is if somebody else is doing the exact same study using the exact same population and they pick out a sample, okay, so I say sample number 2 here, the statistic that is attached to them, okay, is going to be different than the sample statistic out of the first sample. Does that make sense? Okay. And if we do it a third time, they're going to be different, but they should all kind of be in the ballpark of one another. Does that make sense? As long as we've done our research correctly. Okay. One thing we like to do, let's say this class again, is our population, and then we'll go back and talk about the ages that we talked about yesterday. If I take this row, and this row for some reason, and I know the way it's set up, but it's easier to talk about rows, and this would not be a good way of choosing a random sample. Does that make sense? But if this row became a random sample and we found out their average, and then found this row's average,
those two random samples are going to be different, right? Okay. Then if we come over here and find this row's average, they're going to be different, and then you three as a group, your average is going to be different, right? But what we like, and we'll get into this, we'll target this. If I do that, if I take a population and I find 1, 2, 3, 4 different averages, 4 different samples, now what we could do is we could actually take the average of those sample averages. Does that make sense? So I could take this average, that one, this average, and then that last one. We got 4 numbers there. We could average those, and that actually ends up being a better representation of the population. Okay. So that's something that we'll talk about when we we'll talk about the average of the sample means. Okay, so that's all in discussion. When we get the sampling error in our research, it's unavoidable. You're going to have it. It's just inherent. Okay, this idea here, if I'm going to choose different people, and their quantities are going to be, their data is going to be different. So there's going to be error. There's going to be differences. We want to try to, like I said, minimize that. There are a lot of things that we do maybe unintentionally that increases that error. But just like in a lab, like in science or whatever class, like a science, like a chemistry or physics, you do margin of error at the end. We're going to do sample error pretty much every time that we do something, and there's going to be formulas that allow us to do that. Okay, so and determining sampling error, right now just talking about the concept of what it is. Eventually there'll be separate formulas, and that's the thing that early on with this class, a little bit different than other classes. Instead of talking, concept by concept by concept, and then like the first time we introduce sampling error that we talk about it and we get a formula. The reason we don't do that here is because when we get to sampling error, we don't need to want to talk about what it is again. We should already have knowledge of it, and we can just run through that formula, okay? And then we get to another test, and it's a different formula for sampling error. We can just run through that formula with the understanding of what sampling error is from week 1, week 2. Does that make sense? Okay, so the idea here, and this is all stats classes are this way, we're going to build a foundation of knowledge, foundation of essentially the language of statistics. And then that's going to allow us to navigate through the actual procedural things, the calculations, and that kind of stuff as we move forward. We got about another half a day of pure vocabulary, and then part of tomorrow we'll also start doing some actual calculation stuff, analyzing data. All right, so these are some things that we need to be aware of when researching, okay, doing statistics, okay. It says problems with samples. It says a sample must be representative of the population, okay? Yesterday we chose, when we did the ages, we put my name in there, or put my age in there, which is drastically different than you guys. And that skewed the data, right? And it gave a false representation of the average age in this class when my information became part of that sample, okay? So we would want to make sure that we don't maybe do that. My data would be an outlier, okay? And there will be things that we go through in the class that allow us to target and recognize outliers when they exist, okay? But a sample must be representative of the population. Sample that is not representative of the population is biased, okay? And we'll talk a lot today about bias, but biased samples do not allow you to make an argument about the population, okay? Self-selected samples, okay, these are responses only by people who choose to respond. So call-in surveys, mail-ins, or when you got to return something in the mail, those types of things are unreliable, okay? Now, even though they're unreliable, they are still used. People still publish this information, okay? I'm going to come down here real quick where it says misleading use of data, improperly displayed graphs, incomplete data, or lack of context. If you watch the news tonight, you will definitely see one of those 3 things happen every single night. If you read the newspaper, you see that kind of stuff all the time, okay? Whether it was improperly displayed and it was just kind of malfeasance, it wasn't intentional or anything like that, or you might see people intentionally mislead with the data and with the graphs and that kind of stuff, okay? So those are things that we need to pay attention to when working within statistics, all right? sample size issues, if I have a population that's, 103,000, then we talk about Allen County being that big, and my sample is 15 people out of 103,000, that 15 people is not going to be, we can't say that's representative of the population, okay? And then the question is, well, if 15 is not, is 16? And if 16 is not, is 17? Does that kind of make sense? Or where is that cutoff? So there are formulas that are derived from our statistical analyses that we will run through before we do anything. So this is how big, if this is the population, this is how big the sample needs to be for us to be confident in our answers. Okay, so that'll be something that we run through later on. Sometimes, we talked yesterday, if we're testing helmets or something like that, I can't use 2/3 of my helmets to test them. It's not profitable. People that have rare medical testing or rare medical conditions, and they do testing on those and do that type of stuff. My wife has a rare condition called Wegener's disease, which is an autoimmune. There's like very, very, very few people in the United States that have it. And like all the stuff that she went through when she was younger, getting this tested, like the reports and the surveys and data and that kind of stuff, they would always say, well, it's so rare, we don't know if this medication will work or will not work, that kind of stuff. So when you have rare medical, even though there might be some stats out there about it, some survey, or not surveys, but studies out there about it, because the sample sizes are so small, it could be maybe not very reliable information. If we've got 2 people that have a disease and we say, well, we gave them this medication, they both lived, is that really validation that the medication worked? Okay, and if they both died, it really isn't a validation when the medication didn't work. Okay, so sample sizes and studies on small sample sizes is maybe unreliable, but unavoidable. Okay, obviously we can't just go give everybody a condition and then say, okay, let's test to see if we can fix it. Undue influence, and we kind of talked about this. If I coerce you to fill out a survey, maybe I intimidate you to do something, provide data, that's undue influence. Even if if we talk about the Nielsen ratings and they pay you, okay, that's, in my opinion, undue influence. Even the way that you've structured questions in a survey can lead people to one answer over the other. Okay, if I ask you, what is your favorite, let's say, favorite meal on McDonald's menu, but then I only give you 5 options, did I really ask you what your favorite meal on the menu is? No, I've persuaded your thought to at least 1 of 5 options. So I'm really not getting then the full picture. Okay, there are classes devoted to just being able to write questions on surveys that eliminate that type of thing, or teach you how to eliminate that type of thing. Okay, we'll get into a little bit of it. Non-response or refusal to participate. That's kind of like the mail-in or the phone surveys, that kind of thing. Usually you only respond if you have a very strong opinion about something, either negative or positive. Okay, so those can be unreliable. Causality, just because two variables have a relationship, we can't always determine that one is caused by the other. Okay, there may be underlying relationships that are actually binding the two things together. Okay, so that's something that's an issue sometimes. Self-funded or self-interest studies. If I'm, and this is, you see this all the time right now, and we keep going back to politics, and I can't wait till November 3rd is over so we stop talking about them. But the polls that you're seeing right now, if the Democrats are going to make a poll that's self-funded by the Democrat Party, that's something to be thoughtful of. Same thing for Republicans, okay? We need to realize that those surveys, those studies are being funded by that party. So they may try to persuade readers of that statistic towards that party's view. Does that make sense? Okay. Now, there's a whole branch of it's a board of review, basically, where it's a group of people that sit and review studies and determine the ethical components of those studies. Okay. Because of things like this. Okay, they're trying to determine, was the procedure inherently biased because it was self-funded, or there was self-interest in the studies and that kind of stuff. I don't have any proof of this, but a lot of times. So my neighborhood, we weren't connected to city sanitation, city sewage, until like last. I think it was actually this time last year that we were mandated to connect. But they did studies to determine whether we needed sanitation or not. And basically they did soil studies, and they went to like watersheds and did water studies and that kind of stuff. And they determined that we should connect to city sewage. Now, there's a lot of good pros to that. But a con of that is that it cost me up front about $3,000 to connect. Okay, I had to have somebody connect me to that. So I wasn't really all that excited about it. And looking at the study, who does the study to determine whether we should hook up or not? It was the city engineers. Does that make sense? Who does the job then? Who gets paid to put in the sewage? The city engineers. So there's kind of a self-interest there. Does that make sense? Okay. They're the ones saying that I need it because they're the ones that are going to benefit off that profit that they're making off of each person that ties in. So I think obviously that our community needed it, but I could have done without it. But there are things like that in studies that you've always got to think about. Okay. Does somebody have trying to better themselves or better their situation based off of a particular study? And confounding variables, this is something we'll talk about quite a bit. This is when the effects of multiple factors on a response cannot be separated. So you can't determine, let's say we're talking about weight loss, and there are several things that are causing that weight loss, but we can't separate those factors. Okay. When you write a study, something that you do at the onset is you describe all your variables, you describe the type of data that you're collecting, and you describe any confounding variables that might exist. These examples here are just asking us, are these studies going to be representative of the population? Okay, so are these samples that we're choosing going to represent the population? What I want to do here as we go through is not only talk about yes or no, the representative, but then talk about, okay, what is the population? What is the parameter? What is the statistic? What is the sample? Okay, so if I read question, and we'll do that on some, we won't do it on all of them, but some of them. On number one, it says to find the average GPA of all students in a university, you choose to select all members of the dean's list. There's two groups of people here. You got all students in a university, and you've got members of the dean's list. Which one of those is the population, and which one is the sample? Would you agree all is the population? Okay. And the green, okay, the people on the dean's list would be the sample. Now, I want to know, so if I've got a population, here is the data that we're collecting, right? Now, here's my question. Is that data quantitative or qualitative? Quantitative, right? GPA is a number out of 4, right? Most places. So it's quantitative data. Is it discrete or is it continuous? It's continuous, okay? You don't just have a GPA of 1, 2, or 3, or 4, right? You could have a 3.5. You could have a 3.57. Okay, so it's continuous, and that is the parameter. Okay, that's going to be the value or the quantity that describes the population, right? Okay. Now, it's not verbalized here, but would you guys agree that the GPA of the sample is going to be the statistic? Remember, our statistic and our parameter, they have to match. Okay. So when I find one of them, I essentially find both of them. Okay, so now here's the question. Is that representative of the population? No. No, why not? Right. Okay, so your Dean's List, that's like the honor roll, right? So if we just look at the honor roll and pick off, a random sample of the people in the honor roll, and we are going to be guaranteed that their average, their GPA is going to be, that sample average is going to be above 3.0, right? Because everybody on that's 3.0 or above. That's not representative of an entire student population, okay? So we need to make sure that we get all those characteristics of the entire population into our sample. Okay, so no, not a good good representation. Okay. Number 2 says to find out the most popular cereal among young people under the age 10. Okay. You're going to stand outside a large supermarket for 3 hours and speak to every 20th child under age 10 who enters the supermarket. So, we got young people under the age of 10, and then we've got every 20th child under age 10 who enters. Okay? Which one of those is the population? Okay, so the green, so among young people under the age of 10, right? That's our population. The sample then is going to be obviously the every 20th, right? Okay, so that as we go through that process of collecting every 20th, that will eventually be a finite group of people. What am I trying to figure out? What is the parameter? Most popular cereal, right? Okay, and I'm going to be eventually quantifying that with like maybe a pie chart or something like that, and I'll show the percentages, maybe Trix or Lucky Charms, or what kind of cereal you like? Reese's Puffs. Okay, so maybe I've got those, and I'll show maybe one of them's 40%, the other one's 20%, and the other one's 40% again. Okay, but I'll show that in a chart. But there's quantities there. But how did I collect information? I collected information off of a name, right? Is that quantitative or qualitative? If I'm asking you your favorite cereal. Qualitative, right? Okay, so that type of data is what we're looking at there. Let's see here. What kind of sampling would be taking place here? Systematic, right? It's talking about taking every 20th, right? And you can even maybe consider that it's maybe a version of convenience. Anybody thinking that? Because you just go to the local supermarket because that's convenient for you. And that's the thing with some of these studies. There might be a combination of sampling techniques that kind of merge together sometimes. Do you think that would be representative? For some reason, I'm in trouble with that word today. Representative of the population by doing it that way? Would it be more likely to be representative or less? If you're on the fence, which way would you be leaning? Is it as bad as number 1 was? No. Okay. I would say that's probably a good representation or a decent representation of the population. Now, is it just one supermarket? Yeah. Maybe we should do it at a couple others. Okay. Different areas, whatever. But when I say among young people under the age of 10, I guess I'm thinking all young people in the world, right? Or maybe in the nation or whatever. Maybe you should narrow your focus on that. Maybe say, young people in Allen County or something like that, and that might allow you not to have to go to so many supermarkets. But Number 3 says to find the average annual income of all adults in the United States. I don't know why I typed that right there. Okay. So right there tells you your population, right? All adults in the United States. Okay. This number here, average annual income, that's going to be your parameter, correct? Is that quantitative or qualitative? Quantitative, right? Going to be a number there. Okay. It says create a cluster sample by considering each state a stratum, or which is our groups, right? They're already defined groups. And then by using simple random sampling, select states to be part of the cluster. Okay. So this is kind of the structure that they're going through. So I'm not even going to try to draw the United States. Let's just get a picture here. Well, maybe. All right, so the idea is that we've developed this structure, this grouping, and now we're going to go through, and every state is going to get a number 0, 1 to 50, and we're going to simply random sample those out of the numbers table. Does that make sense? And then once we choose those states become my sample, or my cluster, I guess is what they're talking about. And then we're going to go into that cluster, and we're only going to look at the congressmen that are in that cluster. Does that make sense? So let's just say we pick out the yellow states, okay? Those become our cluster. Now we're going to go into that yellow grouping and just pick out the congressmen. Would those congressmen, their salaries be representative of all United States adults? Do we know do you guys know what average congressperson makes? Okay. Now, without they've all got businesses on the side and that kind of stuff, but it's like $170,000 in the ballpark of that per year that they get from the government. Okay. Is that average? No. Okay. So that would be a poor representation of the population. That structure of sampling, I think that's a pretty detailed structure of sampling. I think it's going to get you a good sample. It's kind of a combination of cluster and the simple random. Okay, and I like that technique, but I don't think that then going in and just targeting the congressman is a good idea. Just a side note, how many colors do you need for a graph or a map so that any two states that are ever touching are never the same color? What's the maximum number of colors you need? Nope, not 12. Not that many. And this is any map. This is any map, United States, the entire nation, sorry, not nation, continent, okay? You can go over in Europe and look at all those, and you go to count how many colors are being used. 4. Yep. So something called graph theory allows you to determine that, but you only need 4 colors, no matter what map you're looking at. Not that that's important to statistics or anything, but I think it's kind of interesting. Number 4 says to determine the proportion of people taking public transportation to work, survey 20 people in New York City, conduct a survey by sitting in Central Park on a bench and interviewing every person who sits next to you. Okay. So you can start reading some of these and you could automatically think, oh, that's pretty silly to do it that way, right? Think about this, though. When we read that, when it says the proportion of people taking public transportation to work, is the population all people in the United States? Is it all people in the world? Is it people just in New York City? I think you have to be able to ask that question if you're going to do the study. Does that make sense? I would argue that maybe they're probably talking about people in New York City. Okay. If they were talking about people maybe in New York State or maybe the East Coast or something like that, maybe talking to 20 people in New York City is not a good idea, because what do most people in New York City not have? Cars. Too expensive to park a car. It's too slow to drive it. Okay, there's so much traffic. So that population I don't think is very descriptive in this setup, but we come across that with examples every once in a while. So survey 20 people. So the 20 people would be your sample, right? Okay. How are they sampling them though? How are they getting that 20 people? What technique are they using? Convenience. Okay. And we know convenience is inherently biased. Okay. If I'm sitting in Central Park, those people that are sitting down on that bench, they might all have a similar characteristic. Maybe from day to day, maybe if I do it during like a Monday, and I just sit there Monday at like, let's say, I don't know, 10 a.m., and I just survey everybody that sits down next to me. Aren't most people, if they're employed, working Mondays at 10 a.m.? So maybe a lot of those people sit down to me and have similar characteristics, that they are unemployed, maybe they're homeless, that kind of thing, and it wouldn't give me a good representation of the population. Okay. To determine the average cost of 2-day stay in a hospital in Massachusetts, every 100 hospitals across the state, using simple random sampling. Obviously, the technique we're using, simple random sampling, right? We're going to take every hospital's name on a list, and we're going to put a number 0, 0, 1, all the way to 100, and use a table to generate which ones we pick out. Is that a pretty good technique for sampling? That's the best technique for sampling, okay? Now, do you think 100 hospitals out of Massachusetts is probably enough? How many hospitals are in Massachusetts? I don't know. I would probably say that's probably, I mean, I'm going to say yes. Let's see if Google has an answer. $97 hospitals in Massachusetts. So obviously when they wrote this, or whoever I stole this from, wasn't using like true statistics. So if there's only 90 so we would have essentially done a census. Does that make sense? We would have found data from every place.
Pardon the interruption for an afternoon announcement.